Hi, class. Welcome to the next section, chapter 10.5. Today, we're going to be talking about applications to economics of integrals. So, let's say that we win or inherit $1 million. Okay. That money has a present value, the value it is today of $1 million, right? The average return from investing in mutual funds, which is a collection of stocks, bonds, or other investments, it's generally about 10% per year. Okay, relatively, especially if you have something good that you're investing in. That means that the future value of that $1 million is $1,100,000, right? If I was to invest the whole thing, ideally it would gain 10% in value, right? So if I were to take this $1 million and not spend it all and invest it, 1 year later, I would have an extra $100,000. So the future value is how much the present value of an amount will be worth if I invest it for a certain amount of time. Okay. So we generally call the present value P for present value. R is the interest rate, and T is the time invested. Okay, so generally you've seen this as P as the principal amount, right? So we're going to assume that our interest is compounded annually, so once a year. So we're going to have that the future value is our principal, our present value, um, times 1 plus that interest rate of increase um, for some amount of time, right? Some amount of years. If we compound continuously, you've seen this as PERT, right? So the future value would be that present value times e to the rate of interest increase or decrease times the amount of time that we are investing. So let's go ahead and do an example. So again, let's say that we're offered this $1 million, and we can either take it as four equal payments over 4 years, so a quarter of a million each year in that case, or we can take it in one lump sum of $910,000. Now you might be saying, yeah, no crap, we're going to take the 25, the quarter million, right? That's $1 million. Why would I take a lump sum now that's less than the amount if I just wait 4 years and grab it and get the whole amount, right? But let's go ahead and see, right? So if we get this one lump sum of basically we're taking 90 grand off, okay? If we take one sum. So let's assume that the interest rate right now at this moment of time is about 7% per year, okay? And that's if we compound continuously, right? So they're continuously compounded and such that we're ignoring taxes, okay? So which one should we choose? So let's go ahead and look at this. There's two methods to kind of decide which method we should choose. We can look at the future value of both options, or we can look at the present value of both options. Either way, they should agree with each other. Okay, so let's start off by looking at the future values of both. Okay, for the four payments, um, the first payment is going to earn interest for 3 years. Right, I'm going to get the first payment, and in that year, it'll earn some interest. Okay, then the next year, I'll get the next payment, and that will earn interest, and so will the first payment, and so forth and so forth, right? So the first payment gets compounded continuously for 3 years. The first year, the second year, the third year, and then on the fourth year, it's no longer going to gain interest because I'll get that fourth payment in the last year. So it's only going to earn interest for the first 3 years until I get that last payment, right? The second payment earns for 2 years until I get the last payment. The third one only earns interest for a year, and then I get that last payment, and that's it with the investments, okay, or the potential future values. So when I actually add these all up, it comes to a little bit over a million. Well, a lot more than a million. It's a $1 million and 100,000 and some change. Okay, that's pretty good. So that would be the future value. That's if I invested the whole thing, right? Each time I got a payment, I invested it into this account. This is what it would look like. Okay. The future value of our lump sum over the same period would be this amount that's going to earn interest for 3 years, right? Because the first payment here earns for 3 years. So if I get this at the same time as the first payment, it should be earning interest for the same amount of time. Okay, so for 3 years. And that comes out to actually more than I would if I were to get the four separate amounts. So by comparing future values, my lump sum in this case could potentially earn me more, is worth more to me than four spread out payments of equal value. Okay. So taking the lump sum will result in a larger future value than four separate payments. So that's how I found this out by looking at the future values. I can do this by looking at present values as well, right? So my present values are given by this formula. So if the future value is the present value times e to the RT, I just solve for my my present value. So I'm going to divide both sides by e to the RT. So my present value is my future value times e to the negative RT. So the first payment has a present value of $250,000. Okay. The next payment, a year later, has 1 year of missed potential growth. So it has a value at present of $250,000 minus 1 year of growth that it could have had. Okay. This next one is missing um, 2 years and then 3 years of potential growth. Okay. So comparing the present values, I'm going to have the $250,000 um, that I get at right away. We could say that this is the last one, right? It's kind of like working backwards. Um, the next one is going to be missing 1 year's worth that it can grow. This is going to be missing 2 years worth of growth. And the last one misses 3 years worth of growth, right? So if we add that up, the present value of getting those quarter millions, right, is going to be 903,000, which is less than the lump sum that they would be giving me of $910,000. So the present value of my payment plan is worth less than the lump sum that they would give me. Okay, so that's another way of looking at this. Okay, so the continuous case, right? So this is if I'm getting things paid off one at a time, right? So again, um, the continuous case is what happens if we're making money all the time, right? So if deposits are made regularly enough and the time between the deposits is relatively short compared to the overall lifetime of my account, then we can think of the money as flowing continuously, right? So again, basically what's happening is that I'm getting paid regularly into this account at an interval that is very short compared to the overall lifetime, right? So if I'm getting paid uh, every 2 weeks for like 50 years, that's a short time period in between payments for a very long time, right? So I can look at that as something continuous, even if I'm getting paid monthly over many, many years, okay? So we can think of the money as flowing continuously into the account rather than a bunch of discrete values, right? Single values. And we would call this continuous sort of payment and income stream. Okay. So it's a steady stream of income that can be modeled by a continuous function, which we would call P of T in this case instead of a single amount. And we would look at this in terms of dollars per year. Okay, the present value of that stream of income, M years in the future, can be modeled with this present value formula, which is the integral from 0 to M. That function that models my income stream times e to the negative RT, right? The missed potential, basically, of investing that money. And the future value can be modeled similarly with the integral from 0 to M. That income stream function, e times the rate over the period that it's been invested, right? So n minus t. Okay. So let's go ahead and do an example of this. So very similarly, let's say that we won half of a jackpot. Let's say that the jackpot is $390 million, and we won half of it by playing lotto scratchers or something, picking lotto numbers. Okay. So we're given the option of being paid this amount continuously over 20 years. So every month you're going to get a check, or every, however they're going to do it. But over 20 years is a long time, and they're going to pay us continuously over this 20 years. Or they'll give us one lump sum of $120 million immediately, right? So let's say that the interest rate is 5% at this time per year if it's compounded continuously. Which option should we choose, right? So here we have an income stream. We could do this one by one, but that would take a very long time, right? Over 20 years. Um, it doesn't even say how often we would be paid, right? It's just that we would be paid continuously over this 20 years. So using the present value formula is going to be the easiest because we have a present value. So this means I only have to compute one integral. If I try to compare future values, I have to do an integral for this future value of the lump sum, and I have to do an integral for the future value of um, of the payment plan, of the payment stream. So then I have to compute two different things to compare the future values. Whereas if I do present values, I already have a present value given to me. So I'd only have to compute one integral, so that'd be a lot easier to do. Okay, so the continuous yearly rate is 195,000 divided by 20. So you're saying, where's 195 coming from? It's half of 390, right? So if this was 400, half would be 200,000. So I'm off by 10 million, so half of that is 195 million, right? So this 195 million divided by 20, the 20 years, is 9,750 per year. That's what they would pay me yearly, right? That's the continuous rate. So the present value of that is this 9,750 per year, e to the negative of the potential I'm losing from investing, right? So negative 0.05 t, and we just find this interval, okay? Um, so multiply by the reciprocal of the exponent. So negative 1 over 0.05, 9750 stays there from 20 to 0. At 0, this turns into 1. So I just have this constant, and then plug in 20 as well, right? So when I plug in 20, 0.05 times 20 is just 1, right? So I have e to the negative 1. And when I plug in 0, I get e to the 0 is 1. And this constant stays here in front. Obviously, it makes sense to simplify it. Um, this is the reciprocal function, right? So if I turn this around and multiply it, it's basically 9750 times 20. So I get right back to this function value here. And from here, we just multiply everything out, basically. Okay, so I distribute this 195 across. So this negative and this negative makes it positive, and this negative with this one here makes it negative. And then when I calculate this value, it's 123,000 and some change, which is more than the lump sum. So in this case, the lump sum is not the better option. The continuous payment over 20 years has a higher present value, right? So the present value of the payment plan option is worth more today than the lump sum is, which means that the future value is better for the payment plan as well, right? Especially if I actually were to invest it. Okay. So when we're looking at present value, we're looking at what would happen if we were to uh, not invest, basically. Wait, if we were to invest. Okay. So the payment plan is a better option. Okay. So next we're going to talk about supply and demand curves. A supply curve shows the amount of an item that producers will supply at different price levels. Okay, so the supply curve is how much a supplier will sell you something at a different price, right? So generally for the same item, um, a higher price will make you get a larger quantity of that item, right? So if I buy in bulk, right, if I'm spending more money, I get better price per item. We're not looking at price per item here right now. That would be more so for when we're doing marginal values and derivatives, but we're doing integrals right now, so we're not looking at that. We're not looking at price per item stuff. We're looking at just in general a supply curve, right? The more money you spend, the better value for your money you get, but the more items you'll get, the more you spend. Okay. So a supply curve is representative of the producer, the person who wants to sell you stuff, that makes things and wants to sell it. The supply curve represents the seller, the producer. Okay. The demand curve is representative of the buyer. Okay. It's the demand, right? If I want something, I'm the buyer. It talks about how much I'm willing to purchase for a certain amount of items, right? So it shows how much of an item I'm willing to buy at a given price. So generally, the higher the price, the less I'm willing to pay, right? The higher gas is, the less I want to drive my car around. So this represents the demand and supply curves, right? So we're the ones in red. The people who produce and sell things are the ones in blue. So at some point, these two curves should overlap, right? So the more quantity of we have of something, the more the price it's gonna be, right? The more that somebody wants to sell something, right? The more things that people have, the more you buy, the higher the price. For us, um, the more that we're able to buy, the lower the price, right? If the low price is going down, the more we would buy, right? If it's a low priced item, I would buy more of it. And so at some point, these two things are equal, right? A Q star and P star, right? So it's assumed that the market settles to the equilibrium price, which is this Q star, P star value. Okay, so this is where the market should kind of, it's the supply and demand. It's when supply and demand are equal, that's the equilibrium, right? So when supply and demand are equal, I'm getting a good price, and the supplier is selling at a price that he's comfortable with, and I'm buying at a price that I'm comfortable with, right? That would be the equilibrium price. Notice that at the equilibrium, there's a lower price that suppliers are willing to sell at. Okay, so this is the equilibrium, and the sellers, the suppliers, they would be willing to sell things at a lower price, right? This price value is lower than what it's at. Okay. Similarly, there's a higher price that we're willing to pay, right? So for less quantities, we're actually willing to pay more for less things, right? Again, buying in bulk. I know if I'm going to buy one of an item, it's probably going to end up costing me a little bit more for quantity than if I were to buy like 100 of them. Okay. And so for me, for the demand, if I'm only demanding a few things, I'm willing to pay more for it because I know that that's just kind of how it is. Okay. So again, notice that equilibrium, there's a lower price that suppliers are willing to sell at, and there's a higher price that consumers are willing to pay. So consumer surplus is the total amount gained by consumers when buying at the current price instead of the price they would have been willing to pay at. So it's the measure of the consumer's gains from the trade, right? So it's the total amount gained by the consumer when buying at the current price instead of the price I would have been willing to pay. So it's how much of a deal that I got, right? The consumer surplus is how much of a deal that I get, right? I was willing to pay this much, but I paid this much, so I got a deal. How much of a deal that I get? That's the consumer surplus, okay? The producer surplus is the opposite of that. It's how much the producer gains out of the deal, right? I would have sold this at a lower price, but you were willing to buy it higher than I was willing, to sell it. So I'm making money off of it, right? That's my surplus. That's the producer surplus. It's the total amount gained by the supplier when selling at the current price instead of selling at the price they would have been willing to sell at. Okay. It's the measure of the seller's gain out of the trade. So what does this look like in the graph? This is the equilibrium price. Okay, P star is the equilibrium price that we're both paying or receiving. So here, I would have been willing to pay this much, but I paid this much. So the area from P star and above, that's my surplus. That's how much money I saved by purchasing at this level instead of up here somewhere. And the producer surplus is down here. They were willing to sell low, but they actually sold up here. So from this line below is how much they gained out of selling at this amount. Okay, so that's how you would want to look at this graph. Consumer surplus is the area under the demand curve. Okay, so the demand curve. So under the demand curve, but above P star, it's a consumer surplus. Okay, the producer surplus is the amount above the supply curve, but below P star. So above the supply curve, but below P star, the equilibrium price. So depending on which function we're using, the demand at Q star, at this quantity, at the equilibrium quantity, is the same as the seller's price at that quantity, which is P star, right? So either I'm looking at the demand curve or I'm looking at the supply curve, doesn't matter, because at Q star they're equal and it's equal to that equilibrium price. So consumer surplus. This is the integral from 0 to Q star, the demand curve minus P star. So again, consumer surplus is under, it's everything under the demand curve up to Q star, but above P star, right? So I take all of this and I subtract out of that this P star value, and I'll have everything above it. Okay. Producer surplus is the same thing, 0 to Q star, but here the highest point is P star, and I'm going to subtract from that the area under the supply curve. Okay. Demand Q is for quantity of things bought. The sum of consumer and producer surplus is called the total surplus. So the total surplus is this entire area between the red curve and the blue curve. This entire consumer surplus and the producer surplus together is the total surplus. It is one of the measures that economists use in order to gauge the economic health of a society, right, or um, of a market. Okay, the total surplus is maximized when the market for a good or a service is in equilibrium. Okay, so that's what's going to give us the maximum amount of total surplus, right? The max total surplus happens when we're actually at equilibrium. Okay, so let's go ahead and do an example. So let's say that the demand function for a TV that's produced by an electronics company is given by this demand curve, right? It's a linear function, 228.4 minus 18Q, okay, where Q is the quantity. And the supply function is given by S of Q, which is 27Q plus 57 plus 4. Okay, so here the output is measured in thousands of dollars. So remember, we're plugging in quantities and we're getting out dollars, right? The price. Um, Find the maximum total surplus for the TVs. Okay, so maximum total surplus happens at equilibrium. So first thing we got to do is set these two things equal to each other and figure out what the equilibrium point is, right? So I set these equal to each other, which is the demand function equal to the supply function. So I get all the Q's to one side, all the numbers to the other side, and that will give me Q star, right? So I'm going to um, subtract 57.4. I'm going to add 18, pull out the factor of Q, and then divide that 27 plus 18 that's on the left side over. If you need to do this on some scratch paper, go ahead and do that. We've done this several times, right? So you should definitely be watching this with a pencil and paper in your hand. And this simplifies down to 171 over 45. Okay. simplifies down to 19 over 5. So that's just about 4, right? It's just around 4. So 3.8. P star is going to be 19 over 5 or 3.8, whichever one we want to do, plugged in for Q. Okay, to either function, either the demand function or the supply function. Doesn't matter, okay, because it's the equilibrium point. So if I plug this into, let's say, S of Q, I'm going to get out 160. Okay, so the equilibrium price is 160,000, um, and 3.8 is the demand. Okay, so my consumer surplus is the integral from 0 to Q star to 3.8, and it is going to be the demand function minus P star. Okay, so my demand function 228.4 minus 18Q minus my uh, equilibrium price. So we just combine our like terms, okay, which gives me 68.4. So when I integrate that, that gives me a Q. This turns into a square and divides by half. So we have this here. Very clearly, we plug in 0, this whole thing goes away. So we only have to plug in 3.8 in order to have anything here. That comes to 129.96. The producer surplus is found the same way. I take P star and I subtract from that my supply function. Okay. Again, I can combine my like terms. Okay. Just 102.6. Okay. Minus 27 over 2. Once I integrate this, again, plugging in at 0, it goes away. So I just plug in 3.8 to both terms, and I get 194.94. So the total surplus is the sum of those two things, which is 324.9. So this is thousands of dollars, right? This is a price at this point. So lots of money, right? That is the total surplus. And that's how that works. Okay. Thanks, you guys. I will see you on the next video where we talk about biology, I believe.